I'm going to do the second problem, and we're going to walk through gift, given, implied, freebies, talk through. The most important step is whenever you see overlapping items, overlapping triangles, you should always pull them apart. Just automatically pull them apart. It makes it much easier to work with the proof. If you pull them apart, it's easier to see what's congruent. So I'm going to trace an outline so it's easy to see these. And we're going to take this one triangle, EFG, and I'm going to pull it apart right here so it's easy to see it. And this is E here. This is F and G. Then we have our other triangle. And this is E, again, H, and D. We're going to use this triangle, these two triangles, to try to prove what we're trying to prove. Well, let's go through the given, the implied, the freebies, and talk through. So we're going to read and mark the given. We're given that EF is congruent to ED. So EF is congruent to ED. If you look here, that means this whole side is congruent to this whole side. That's our first pair of congruency. That's actually a pair of congruent sides. Then we're told that EH is congruent to EG. So EH and EG, and that's these two pieces are congruent. Back on the original diagram, that's another pair of sides. We're trying to prove that angle F is congruent to angle D. There's no direct way to prove those individually, but if we can somehow get the triangles congruent, we can then say that angle F is congruent to angle D by corresponding parts of congruent triangles are congruent, which basically means if the triangles are congruent, then the parts are congruent. So we need to get the triangles congruent here. So let's see what else is implied. We've done given. We're going to talk about implied and freebies. If you look very carefully, we can see that angle E is shared by both triangles. Angle E is shared by both triangles. So let's do that on the pull-out triangles. Aha! Now, it's quite easy to see why are these triangles congruent, because of side, angle, side. And if the triangles are congruent, the parts are congruent. The triangles are congruent, the parts are congruent. So we're going to write a two-column proof that heads up side, angle, side. So we're going to work with the I know that because statements. So step number one, we're going to be shooting for side, angle, side. So let's start with what we do know. We know that ES is equal to ED. And that gave us our first set of sides. So I'm just going to put that side there. And the reason why we know that, because it is in the given. Next one. I know that angle E is equal to angle E. Now, I know that looks a little strange, something equal to itself, but that's called the reflexive property. We're saying it's the reflexive property of angles. Reflexive means it's shared by both triangles. That's what makes it reflexive. It's shared by both. It's congruent to itself. This gives us our pair of angles. We have a first pair of sides, and we have a pair of angles. Number 3, we know that EH is equal to EG. That's another pair of sides. Why do we know that? It is in the given. Now, because we have side angle side, we can then say that triangle EFG is congruent to triangle EDH. And why do we know that? Because of the side angle side congruency shortcut. Once the triangles are equal, then we can say the parts are equal. Therefore, we could say that angle F is congruent to angle D because of corresponding parts of congruent triangles are congruent, also known as if the whole triangles are congruent, then the parts are also congruent.